Hey guys! Alright, so let's talk about this exponents test review. This part one lists out the exponent rules. I'm not actually going to go through and write them all out for you guys, but let's just talk about it. Whenever we're multiplying things of the same base, okay, so that's like something that has like b to the second power times b to the third power, stuff like that, we're going to add their exponents, okay? Whenever I'm dividing, I'm going to dividing things of the same base. Okay, remember dividing things of the same base, I'm going to subtract their exponents. When I have a power to a power, I'm going to multiply their exponents. When I have a negative exponent, I am going to move him down into the denominator or vice versa. And when I add or subtract like terms, okay, that's your combining like terms. We don't do anything to the exponents in that case, okay? We're just adding them, combining like terms. And then remembering anything to the 0 power is 1. Okay, that's our favorite rule. Anything raised to the 0 power is just the number 1, not 1x or x to the first power or anything like that, just 1. Wrong button. Alright, sorry about that. Now down here into part 2, simplifying exponents. So this is where I'm going to actually go through and work through these guys with you. Now remember, if it helps you to go through and fill in, if it helps you to fill in like your missing exponents, so not your missing exponents, they're the little invisible ones that we have out there. So remember, this is 3 to the first power, x to the first power, y to the third power, and this whole base is being raised to a power of 4. So this is the power to a power rule. We're going to distribute our powers to the powers, okay? So that's going to end up giving me 3. 1 times 4 is 4. X to the first 1 times 4 is 4. And then 3 times 4 is 12. Okay. Now this part out here in front, we can actually evaluate that. 3 to the 4th power, if you chunk that into your calculator, you're going to end up getting 81. And then x to the 4th, y to the 12th. Okay, so there's our final answer for that guy. Let's look next door here. We are going to be using, hopefully you're looking at this, you're like, okay, these things are being multiplied. We're going to use the product rule. Again, go through and fill in your little 1 exponents if that helps you out. So this is 2 to the first power times 2 to the first power. So whenever they're the same base, we add their exponents. So that's going to give us 2 to the second power, or you can just look at it as 2 times 2, which is 4. And then we have our x's. Well, there's no other x's on the right side for me to multiply him against, so he's just going to stay there by himself. And then I have y to the second power times y to the first power. And remember, we add our exponents, so I'm going to have y to the third power there. All right. Alright, next door over here, I'm seeing we have a fraction happening or a division problem. We're going to be using the quotient rule. I'm sorry, yes, we're going to be using the quotient rule. So remember, we kind of tried to step back and look at this and say, okay, where is it going to be better for me to move my m's to? Is it going to be better if I move them to the top, or is it going to be better if I move them to the bottom? Remember, the ultimate goal here is to keep our exponents in the positive side of things. So we're going to keep our 2. 2 over 1 doesn't reduce to anything else. So we're going to keep that 2 over here. Now I see I need to move my m's to the top. Remember, whenever we're dividing things of the same base, we're going to subtract their exponent. So whenever I move this m to the top, I'm going to subtract 2 up here. So 3 minus 2 is 1. Okay, it's not necessary for me to put that 1 exponent up there, but you can if that helps you. Now I'm looking here at my n's. I see if I move these 4 n's to the top, that's going to give me 2 minus 4. 2 minus 4 is negative 2. So to avoid that, what I'm going to do is actually move my n's to the bottom. And I'm going to do that. We still do the same thing by subtracting our exponents. So this will be over 4 minus 2 is 2, so we get n to the second power. All right, this one over here on the bottom left-hand corner, remember we always look at our whole numbers first. I'm looking at 4 and 2. 4 divided by 2, that reduces if you think about either 4 divided by 2 is 2, or if I divide top and bottom by 2, we're going to end up getting 2 over 1. Now we're looking at, there's some negative exponents happening, so be careful for your double negatives. Go ahead and fill in your little exponents if that helps you. So we have x to the first power on top, y to the first power on the bottom. So now let's go ahead and move our x's to the top, okay? So this is x to the negative second power. So remember, be careful for those double negatives if I'm talking about the top up here. This is going to end up being x to the first power minus a negative 2, okay? Now, what do we call this right here? Hopefully you're thinking a double negative. What do we do to double negatives? We change it into a plus sign. So up top we're going to end up with 2x to the third power. Oops, sorry, that's kind of wonky. Oh, it's getting worse. Okay, now let's look at our y's. Kind of the same thing is going to happen up here. If I move this 1 up to the top, that would be negative 3 minus 1. He's still going to end up being negative. So instead what I want to do is move my y's to the bottom. So I'll kind of show you that over here. So we have y to the first power. I'm moving the negative 3 down, so it's minus a negative 3. Again, we have another double negative. That's going to end up being y plus 3. Y to the first power plus 3. So this is going to end up being over y to the fourth power. All right, and we get that final answer there. Again, sorry about my little janky 3 right there. He's kind of cute though. All right, next in this other guy, we have the product rule. The product rule, once again, whenever we multiply things of the same base, we add their exponent. So go through and add your little exponents in there if you need them. So I have 4. So our 4's will multiply together. Again, you can think of that as adding their exponent. So we get 4 to the second power, which is 16, or just think 4 times 4 is 16. Now I'm going to look at my x's. I have 3 x's right here, another 3 x's over here. Whenever we're multiplying things of the same base, we add their exponents. Same with my y's. I have 3 over here times one of them over there. We're going to end up with y to the fourth power. And I don't have any z's on this side for him to multiply by, so he's going to stay the same. And there's our final answer there. All right, on this next one, hopefully you're seeing we have power to a power. So go ahead and fill in that little exponent if you need them. And now we're going to distribute our powers to powers. Remember, we're not saying 3 times 2 here. We're multiplying it to our exponents, okay? So we're going to end up there with 1 times 2 is 2. And then I have my x's. 3 times 2 is 6. And then my y's, 2 times 2 is 4. Now remember, after we do this, we need to evaluate the number out there in front. 3 squared is 3 times 3, so we know that's 9. X to the 6th power, y to the 4th power. And there's our final answer there. All right, and these last two, hopefully you remember this from the very first day whenever we started working with our exponent rules. We're just adding polynomials. So remember, if there's a positive, or if we're adding these two things together, we don't necessarily have to go through and distribute that positive one. Everything is just going to remain the same. So let's go through and combine like terms. So I have x to the 3rd power right here, and another x to the 3rd power here. So I have a total of 2 plus 5. It's going to give me 7 of those guys. 7x to the 3rd power. And then I'm going to look at my plain old Jane x's. I have positive 4x's over here, and then negative 9x's over here. Don't forget to include that sign with him. So negative 9x and a positive 4x is still going to give me that negative 5x. And then last I have negative 8 and positive 12. Negative 8 and positive 12 is going to be a positive 4. Now in the second guy, we got a couple little things happening over here. So first, remember, hippity hoppity, Distributive property. I know y'all are saying it. So let's go ahead and do that. And then remember in the second part, remember right here, whenever there's that minus sign, we can assume that that's a -1, in which case we do need to distribute that -1. So let's go through and see what that's going to look like. 2 times 3m squared, it's going to give me 6m squared. 2 times positive 6m is positive 12m. And then 2 times -12 is -24. Now I'm going to go through over here and distribute this -1. Okay, don't forget whenever there's that negative or this minus sign when we're subtracting, then we got to distribute that negative. So that's going to give me -4m squared. A positive, remember a negative times a negative is going to give me a positive 3m. And a negative times negative is going to give me a positive 12. Now we're not done because we still need to go through and we need to combine like terms. So go through and circle, highlight, do whatever you got to do. So I have some m squareds there, some m squareds there, some regular m's right here, some more regular m's right here. And then I have my fun little whole numbers. So let's go through and see what these things are going to add to be. 6m squared and -4m squared. Again, don't forget to include the sign with him. So that's going to give me a total of 2m squared. I have positive 12 and positive 3m's. It's going to give me a total of 15m's. And then I have -24 and positive 12. Okay, if you're not sure what that is, -24, positive 12, still going to be -12. And there's our final answer. Alright, part 3, word problems with exponents. So I know we haven't really talked a ton about these, but they're pretty easy and I think y'all are going to do great. So which expression represents the area of a rectangle with the sides measuring x squared times y and 2xy squared? So if you need to, draw yourself a little picture. Label your sides. So one of them is going to be this, and then the other will be this. So area, hopefully you remember that the area of a rectangle, or the formula that we use there, area is equal to length times width. Alright, so ultimately all we're doing is going to be multiplying these two things together. So I have the area of this rectangle is equal to x squared times y times 2xy squared. So now we've seen this, we're just going to be applying the product rule here, remembering that whenever we're multiplying things of the same base, we add their exponents. So go through, fill in your little 1 if that helps you. And remember, we're going to add their exponents. We can also assume that there's a 1 out here in front. So 1 times 2 is 2. Now my x's, I have 2 over here times 1 of them over here. That's going to make for 3 of those. And then I have 1 of my y's over here times 2 of them over here. It's going to give me a total of 3 of those guys as well. So the area here is 2x cubed, y cubed. So I see that here, letter choice A. Now on this next one, the volume of a cube. So the volume of a cube has a side length of this. So the volume for a cube or a prism, which sometimes some people would say, well, that's equal to length times width times height. Okay, and that's fine and that'll work for you, but notice that with a cube, well, the length of this is going to be the same as the width and the same as the height, right? For a cube, all the sides are going to be the same. So another formula that we sometimes use for volume of a cube is volume is equal to side cubed, which makes sense, right? Because we're just multiplying the same length of the side 3 times. So let's go ahead and see what that looks like. That's going to give us volume is equal to 2x squared times y, all raised to the 3rd power. Okay, don't forget to put this guy in parentheses, and now we're working with the power to a power rule. So go ahead and fill in your 1's if you need them. Remember, power to a power, we distribute powers to the powers, and whenever we do that, we multiply. So let's take the party up here. So I'm going to end up with the volume of this cube is equal to, whenever I distribute this 3 here, 2 to the 3rd power. Okay, you can kind of do this. Oh, we got some lag. 1 second, guys. Alright, sorry about that. So here we go. Again, we're going to distribute this, so that's going to give me 2 to the, Shoot. Sorry about that, guys. Computer was lagging. Okay, so right here, I went ahead and finished writing it out whenever I distributed that power. 2 times 3 is 6, and then 1 times 3 is 3. Remember, we need to evaluate this last part. If you don't remember what 2 to the third power is, plug it in your calculator, and that's going to give us 8, x to the 6th power, and then y to the 3rd power. All right, that